When two events A and B occur simultaneously, then probability of A and B both happening simultaneously is given by probability of A times probability of B. Now, as probability of any given event is between 0 and 1, notice that probability of both the events occurring simultaneously, probability of A and B, is always less than probability of the individual event, right? So it's less than probability of A or probability of B. I mean, for example, say the probability of A is zero point 0.5, probability of B is zero point 0.6. So the probability of A and B both happening would be zero point 0.5 times zero point 0.6, which is 0.03. Now, 0.03 is clearly less than 0.5 or 0.6, and that makes sense, right? Probability of one event occurring and two events occurring, the two events occurring must be less than probability of just one event occurring, right? Now let's take some examples. Say there are 3 science books and 4 history books, out of which Alex randomly picks 2 books. What is the probability that Alex picks 1 science and 1 history book? Now, since the order in which the books are picked does not matter, right? It does not say that pick first science book and then a history book or the other way around. So in that case, there are 2 ways of solving this question. The first method is we find the total number of outcomes, basically all possible events. Now, all possible events is picking any 2 books out of 7 books, right? So any unique combination of 2 books out of 7. So we are referring to the formula for combinations, which is 7C2, which is 21. So 21 is the total number of outcomes, right? All possible events. Now, out of this 21 outcomes, how many of them contain 1 science and 1 history book? That is your number of desired outcomes. So in this case, it is 3C1 times 4C1, which is equal to 12. So the probability of picking 1 science and 1 history book is 12 over 21, which is 4 by 7. Now the other way of solving this is finding the probability of one event at a time. So assume the order in which the books are picked is science book picked first, followed by a history book. Then the probability of picking a science book first is 3 by 7, right? There are in all 7 books, 3 of which are science books, so the probability is 3 by 7. Now, the probability of picking a history book second is 4 by 6, right? Why 6? Because now the books left are 6. One book is already picked. So out of which 4 are history books, so probability is 4 by 6 in the second turn. So the probability of picking a science book followed by a history book is probability of 2 events occurring simultaneously, right? The 2 events are science and a history book picked in this order. So which is 3 by 7 times 4 by 6. But since the question does not mention the order, we also need to account for the other order, right? A history book picked followed by a science book. The In this case, the probability is 4 by 7 times 3 by 6. So the probability of picking 1 science and 1 history book is adding these 2 probabilities. Now notice that both the probabilities are the same, right? This one and this one. So we just multiply this probability by 2 to get the final probability. So 2 times 3 by 7 times 4 by 6 gives 4 by 7. Now this number is exactly the same as uh, we got using the other method. Now take another example. Say 2 coins are tossed. What is the probability of getting first a head followed by a tail? Now the order of the outcomes in this case does matter, right? We want first a head followed by a tail. So the probability of getting a head on the first coin is 1 by 2, right? Because a coin has only 2 outcomes, head and a tail. The total number of outcomes is 2, and the number of desired outcomes is 1, right? Basically, we want a head. Now, the probability of getting a tail on the second coin is also half, right? Because again, it's 2 outcomes. Now, one outcome is tail, one is a head. Now, since we want tail on the second outcome, it's again 1 by 2. So the probability of getting a head followed by a tail is basically probability of 2 events occurring simultaneously, which is probability of head and tail in this given order. So it is 1 by 2 times 1 by 2, which is 1 by 4. Take another example. If the probability of raining on any given day of the week is 0.3, what is the probability that it rains on Monday and on Tuesday, but not on Wednesday? Now, probability of rain is zero point 0.3. Probability of no rain is 1 minus zero point 0.3 is 0.7. Why? Because sum of the probability of all the events is always 1, right? In this case, there are only 2 events. So probability of rain plus probability of no rain must equal 1, right? Must equal 100%. Either it rains or it does not rain. So the probability of no rain is 1 minus zero point 0.3, which is 0.7. Now, here there are 3 events that must occur simultaneously, right? So the 3 events are that it rains on Monday, that it rains on Tuesday, that it does not rain on Wednesday. So the probability of rain on Monday, rain on Tuesday, and no rain on Wednesday is zero point 0.3 times zero point 0.3 times zero point 0.7, which is this. So basically all 3 events must occur simultaneously. So that's why this. And again, notice that this number is much smaller than 0.3 or 0.7, which makes sense.